Okay, so let me just do a summary of the first law of thermodynamics and the work done by the pressure. So over here, the only thing you need to remember is that if you deal with the definition of the first principle of thermodynamics, Q minus work equal to change in energy. In this case, the definition you have for the work done by pressure, generally will be work done by pressure, will be equal to plus P dV. Using that definition, the definition of the work done for constant pressure would be equal to P V2 minus V1. For the polytropic process, so you have two cases over here when n equal to 1. In that case, the work done by the pressure will be equal to P1 V1 log V2 over V1. And when n will be different than 1, positive integer, and different than 0, the work done by the pressure will be equal to 1 minus n P2 V2 minus P1 V1. So end of story. If you have this definition for the first principle of thermodynamics, this is the definition for the work done by the pressure, and these are the three expressions we derive. Okay, so if you want, you can just use this page to do the homeworks of the problem if this is the definition used in the textbook you are having for your class. Okay? So now, on the other hand, if the definition you are using is Q plus work equal to change in energy, in that case, the definition for the work is minus P dV. And for the same three cases, we have for P constant, for polytropic process, n equal 1, n different than 1, different than 0, and positive integer. So basically we have exactly the same expressions, but with in front a negative sign. Okay, and something important also that I want you to remember, or to know, not to remember, but to understand, is that the work done by the pressure if you calculate it graphically from a PV diagram, will always be equal to the area under the curve. Okay, so basically this is for the definition of the first principle of thermodynamics. This is for this definition. If I remember properly, I think your textbook uses this one. But anyway, at the beginning of every single problem, depending from which textbook the problem is coming from, I will define if it's coming from this definition or this one over here. All right, thank you so much for your attention.